Hi y'all, this lesson is on solving systems of three equations instead of two. And we use three equations because there are three variables. So the more variables there are, the more equations there are basically, but we're just going to cover three today. When I say three variables, I mean that there are three things that are unknown to us. So this might mean maybe it's a concession stand and there's three different items being sold or something like that, and we need to know the price of each item or how many of each item sold. Things like that is where you can apply this. But we will start this lesson. We've got basically, we're going to be using substitution and elimination to help us narrow down the variables. So if you're unfamiliar with substitution and elimination, you might want to go back and watch those. And we're going to use, when I said narrow down the variables, I mean we're going to basically pick two equations. We're going to use elimination on those two equations to get rid of a variable. And then we'll pick two different equations, get rid of the same variable, and then we're just kind of like whittling our way down until we can finally get it to one variable where we have it solved. A solution to three equations is written x comma y comma z. With two equations or two variables, it's just x comma y. The z kind of introduces this third axis that it's kind of like a diagonal axis, but it's really like a 3D type thing. It's hard to explain, not the point of the lesson, but that's how you are going to write that coordinate. We've got a system below. Remember, a system is two or more equations. And I am going to pick, actually, this is a really good habit. I would go ahead and label these equations. And then that way, as you work your way down, you're knowing which equations were used, basically. And when you refer to them, you know what you're talking about. And I am going to use equation 1 and equation 2 to eliminate z. And I chose to do that because I see a negative z and a positive z. And I know that those are going to eliminate very quickly. So I'm going to use equation 1 plus equation 2, x plus 4y minus z is 20. 2x, whoops, that is not right. 3x plus 2y plus z is 8. And I'm adding the two equations. And when we add the two equations, we get 4x plus 6y equals 28. This is a new equation. And you'll notice in this equation that there is only an x and a y. So now I need to use two different equations to eliminate z again. And you can either use 1 and 3 or 2 and 3. But you don't want to use the same two equations again because we've already used them. But we do want to eliminate z. So I am going to choose to use, let's see, equation 1. And I'm going to multiply by 2 plus equation 3. And the reason I did that is because I noticed that these had opposite signs, but this needs a 2 for it to be eliminated, which means I'm going to have to multiply the whole equation by 2. I've got 2x plus 8y minus 2z equals 40. And then I'm going to leave this one alone. And like I said, there's not only one way to do this. If you had chosen equations 2 and 3, you're going to get a different equation from the result, but you'll get the same final answer. We get 4x plus 5y equals 24. And this is equation 5. We've created a new equation from this. Now I'm going to use equations 4 and 5 to eliminate another variable. It does not matter which variable you choose to eliminate. I prefer to eliminate x in this case because we have a 4x and a 4x, and all I have to do is subtract the two equations. So I'm going to take equation 4, subtract equation 5. 4x plus 6y equals 28, minus 4x minus 5y equals negative 24. So the x's go away. They don't go away. They add to 0. And we get y equals 4. Yay! There's your first answer. We have the y coordinate of our solution. Now you're going to back substitute. So you're going to take y equals 4, plug it into either equation 4 or 5 to find x, and then you'll take x and y to back substitute into either 1, 2, and 3. So let's do that. I provided lots of room, thank goodness. So I'm going to do y equals 4 is going to get plugged into, I'm just going to pick equation 4. It does not matter. It won't make a difference. You're going to get the same answer. And solve 4x. So we got 4x plus 6 times y equals 28. That's 4x plus 24 equals 28. 4x equals 4. X is 1. Now I've got x and y, and all I have to do is find z, which means I need to use one of the equations that actually has a z in it. I'm going to use the first equation. Doesn't matter. You can pick any equation. Since these three lines intersect at the same one point, then no matter what equations you use or what combination of equations you use, you're going to get the same 1 point as I do. So x equals 1 gets plugged into equation 1 and solve for z. So we get x plus 4y minus z is 20. X is 1 plus 4y minus z is 20. I want to make sure I wrote that down correctly. Plus 4y minus z. Okay. 1 plus 16 is 17. I'm going to subtract it to the other side. Divide by negative 1. And dun, 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 I've got all three coordinates of my solution to where these three lines intersect. So my answer is x, y, z. And just to check it, that point would have to fit every single equation. So you can plug it into every single equation, and if it fits every single equation, then we know that we got the right answer. So go ahead and plug it in and try, see if it's good. And you should see that they all work. Just to kind of show you one of the examples, you take each variable, plug it in, and that does work, and it works for every one of them. Next page, we've got a couple examples down here. I like these where one of the equations already has only two variables. So that kind of helps you narrow down what you need to do to eliminate. I am going to label my equations. And I'm going to, basically my only option is to use equations 1 and 3 to eliminate y, because I want it to have these variables, which means I need to eliminate y. And to do that, I've got to do negative 2 times equation 1. That kind of got messy. There we go. To get negative 2x minus 2y minus 4z equals negative 34. And then plus equation 3 x plus 2y plus z equals 16. And then simplify. We get negative x minus 3z equals negative 18. Now go ahead and pause it and try to finish it on your own, and then come back and check. Your next step is going to be to take equation 2 and add it to equation 4. Equation 2 is x plus z equals 8. Equation 4 is negative x minus 3z equals negative 18. These x's add to 0. We get negative 2z equals negative 10. So z is 5. Excuse me. Now I can plug that in. We can back substitute into either this equation or this equation to find x. So we've got x plus z equals 8 for the second equation. Subtract 5 to get 3. And now we use x and z to find y. I'm going to use equation 1. X plus y plus 2z is 17. And then subtract 13 to get 4. So the solution to this system is 3, 4, 5. Ooh, I like that. That's fun. So for this last one, I want you to pause it and try it on your own. Really give it a good try. Try to finish the whole thing before you hit play. And then when you're done, hit play and check it with mine. I was going to write the whole thing out and then let you check it, but I'm going to show you where I'm at so far because it does get a little, not messy, but a little confusing as to where I'm going. What I did first was I chose to eliminate y, and I used the first and the second equations to do it. And I got my equation 4. Now, if you chose something else, that's fine. Don't erase your work yet. And then I used equations 1 and 3 to eliminate y again. I had to multiply the first equation by 4 in order to do that. And then I took equations 4 and 5, and I actually had to multiply by negative 13 on the fourth equation, which was kind of like, ooh, but it turned out great. And I ended up with some big numbers here. You could have chosen to multiply this one by negative 6 and this one by positive 4, would have been fine, but I just wanted to multiply once. And I ended up with negative 46x equals negative 46, and I got x equals 1. So that's where I'm at so far. And now I'm going to back substitute. I wish I had some more space, but that's okay. We've got 4, I'm going to use equation 4. 4 times x plus z is 6, so z is 2. If I subtract 4. Now I'm going to use equation 2 to find y. 3 times x plus y minus 2 times z equals negative 2. That'd be 3 minus 4 would be a negative 1. Add the 1, and we get our y value. So your final answer should be 1, negative 1, 2. Then it's always a really good idea to plug in your answer into every single equation and make sure that it works. That's a really great way to just check and make sure that you're getting the correct thing, especially if you're taking a test. And I plugged them in and they do all work, so we're good to go. This last one is an example of a word problem. This one's kind of a little puzzle. Well, all math problems are kind of little puzzles. Some of them are really big puzzles. But we've got we're going to be writing 3 different equations. But before we can write our 3 different equations, we need to define our variables. So what are the 3 missing pieces, basically? And as you write this, you can use whatever letters you want. I typically stick with X, Y, and Z. The sum of 3 numbers is 16. The sum of twice the first number, 3 times the second number, and 4 times the third number is 46. And the difference between 5 times the first number and the second number is 31. Find the 3 numbers. It's always a good idea to just do a read through of it to see what it's asking. And it's asking us to find these 3 missing numbers, which means that I need to define my variables. X is going to be my first number, Y is going to be my second number, and Z is going to be my third number. The first equation says, the sum of the 3 numbers is 16. Sum means total, which means add. X plus Y plus Z is 16. My second equation says the sum of twice the first number, 3 times the second number, and 4 times the third number is 46. So twice the first number, 3 times the second number, 4 times the third number is 46. And then the last one, the difference between 5 times the first number and the second number is 31. The difference means subtract 5 times the first number and the second number is 31, which looks like this is nice because we've already got one equation that has only 2 variables, which means that we can use these 2 equations to eliminate Z, since we're missing Z here. You do want to label 1, 2, 3 your equations. And we are using, let's do -4 times equation 1. -4x minus 4y minus 4z equals -64, plus equation 2. 2x plus 3y plus 4z is 46. We get -2x minus y equals -24. That's not right. -18. Sorry about that. That's performance mistakes. I don't know. We all make mistakes, whatever. So we get -18 there. This is equation. This is equation 4. I'd like to say I only make mistakes on video because I'm like nervous, but that's not true. I make mistakes all the time. So there's that. Hush. All right. Now we need to use equation 3 and 4. So equation 3, I've already got written in orange. I'm not going to rewrite it because I'm running out of room. I need to multiply negative times equation 4. And I get positive 2x, positive y equals positive 18. We get 7x equals 49, which makes x 7. And now we can back substitute and find y and find z. So go ahead and pause it and do that. You should find once you solve for the other variables that y is 4 and z is 5. When you plug those into every single equation, they come out to be true statements. Therefore, our solution is 7, 4, 5. So our first number is 7, our second number is 4, and our third number is 5. That is all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know and I would be happy to help.